Hello everyone, my name is Mahir Hussain. I am from Savita Engineering College, CAC department, third year. Today I am going to give a presentation on my mini project. The topic of my mini project is diabetes prediction using machine learning. Now in this video, we are going to see about the introduction, the statement of the problem, the scope of the project, methodology, then the evaluation results, then conclusion, then future works. What are the future works that are there, and the references that I use for this project. Now let's get into the introduction. Uh, Diabetes is one of the most common and serious chronic disease globally. According to the medical reports, and millions of people suffer from diabetes, and many remains undiagnosed for years. During the early stages, symptoms are often mild and are not noticeable, but damage to the organs like heart, kidney, eyes, nerves may already begin. Early detection is critical because timely lifestyle changes and medical interventions can prevent or can be delay complication. However, traditional diagnosis requires laboratory tests and access to healthcare facilities which may not be easily available to everyone. Our project addresses the issue by developing a machine learning based prediction system that analyzes the routine medical data and predict whether a person is risk of having a diabetes or a particular disease, in type of diabetes. That's basically our project. So we are going to use a machine learning to predict this output. Now, the statement of the problem. Statement of the problem is like I said, diabetes often goes undiagnosed in the early stages, because people doesn't get the symptoms until it becomes late. So this is the reason why we have decided to create this project. Now let's see about the scope of the project. Scope of the project is utilizing machine learning algorithm to predict the likelihood of having a diabetes based on health related input features. Then focus on analysis the data sets like PIMA diabetes dataset to identify key factor influencing diabetes risk, and like covers data pre-processing and feature selection and model training and evaluation, and comparison of classification algorithms. It provides a foundation for developing a simple screening tool that can support early risk identification. Limited to prediction based on available data attribute, does not include medical diagnosis or real-time patient monitoring. It depend upon all already it is entirely based on available data set. It doesn't really work on real-time patients. It uses the data that have been collected before to predict to whether a person has the probability to have diabetes or not. This can be extended in the future with large data set and additional health indicators and integration into healthcare applications to even make it a real-time monitoring as well. Um, you know. Now we are going to see what are the things that we have included and then exclusion. In diabetes prediction, we have inclusion of data pre-processing steps, including handling misvalues and scaling and feature selection. It pre-processes the data set to handling missing values, scaling and feature selection problems. Analyze the health parameter, it analyzes the health, glucose level, blood pressure, and BMI, insulin, age, and pregnancies. Many factors like this to develop predictive models. Exclusion is that we don't have any real-time medical data collection or live patient monitoring does not provide a clinical diagnosis or replace medical consultation. It is just a prediction method. It does not conclude, entirely remove medical diagnostics, because still medical diagnosis is required, but this can be used to predict the probability of having it, so that we can go seek medical attention early. The limitations are, the data set we used is PIMA data, diabetes data set, and it has a total records of 768 samples with multiple medical attributes. And limitations are, data set size is limited. As I said, it uses a small data set. In future it can even be developed into huge data sets, which may, this small data set might affect the model generalization. Some features in the data set have missing or zero entries, reducing accuracy despite pre-processing. There are some data missing values or zero entries. It reduces the accuracy of the overall result. The predictions are totally statistical and not clinical diagnosis. This model performance depends heavily on the data set quality and feature relevance. External factors like lifestyle, medication history, genetic data, diet are not included, which could improve prediction accuracy. Result may vary when applied to different population due to demographic variation not captured in the data set. This other regions might have a different lifestyle, diet, etc. So this data might not be able to apply to different population. The methodology of my project is follows as, first is data collection. The data set imported from, as I said, PIMA diabetes. Then the data is then pre-processed, like it removes missing values, zero values. It is then scaled and normalized, splitting then the data set is split into training and testing sets. Then the feature analysis, understanding relationship between health indicators and data diabetes risk. Model selection we have used is decision tree, random forest, SVM, and NIMBIAS. Model training and testing. Models are trained on labeled data and evaluated using accuracy and recall and confusion metrics. Then results are evaluated. Comparison of the output finalized better. We have used you have compared the different outputs to improve to finalize the best performing model. Then the implementation output example is that we have visual confusion matrix to evaluate true positive and false negative. Best performing models was selected based on the evaluation metrics. Accuracy comparison was like random forest did 89% and SVM did 85%, and decision tree did 81%, and NIMBIAS did 73%. Then the tools we have used are Python. Then the libraries we have used are Pandas, NumPy, Scikit-learn, Matplot library, and Seaborn. Then platform we have used to apply this is Jupyter Notebook and Google Colab. The dataset we have used is PIMA diabetes dataset, and the algorithm we have used is NIMBIAS, decision tree, random forest, and SVM. Now let's get into the code of this project. As you can see, first we have this is a code of a project. Let's go one by one. As we have seen, we have imported the required libraries such as Pandas, Matplot library, and NumPy and Seaborn. Pandas is used for loading and manipulating the data sets. Matplot library is used to data visualization. Then the NumPy is used for numerical operations, and Seaborn is used for advanced statistical visualization. Then we have we have imported SKLN matrices, and model we have been selected as train test split. Uh, then Then we have read the data. We have then read the data using this code, and uh, and we have we have displayed the number of rows and columns in the data set. Then we have displayed the first 5 records of this data set using this, and then we have you know used this data.corr, which is, it is used to it is intended to calculate correlation between features. Missing parentheses, correct form should be uh, you know uh, uh, then then we have selected the then we have done the feature selection. Then we have set the target variable. This We have used the feature column to store the independent variable, and the predictor class to store the dependent variable. Then converted the feature into xy for easier run, and and we have split the data into training data and testing data, so like 70 and 30 percentage. And then using this, we have imported uh, Gaussian naive Bayes model. Uh, and Sorry, give me a minute. I'm really sorry. And as you can see, we have used dot travel, which is nothing but you know it it converts the target data into 1D array. Uh, then we have calculated and prints it prints the accuracy of the naive Bayes model. uh, then this spot creates creates and trains decision tree model. uh, then we have used this code to predict the results and calculate the accuracy. And we, and this spot is used to uses this spot uses SPM with linear kernel for classification. Then and finally trains random forest model, and it makes prediction and evaluates the accuracy. These steps we have used for each and every model. So we get the accuracy accuracy of every model. And this is the output that we get after implementing the code. As you can see, we have gotten the accuracy for level. And here too we have got the accuracy level of the SVC kernel, linear kernel. And here we have, again we have got the accuracy level of the random forest model. And So thank you for watching this video, and this is my project on diabetes prediction using machine learning for my mini project. And finally, my name is Mahir Hussain, and I'm from Savita Engineering College, CAC department, third year. Thank you.